Hello, everyone. Thank you for joining this first presentation. As it's the first in the morning, I can see that it will be quite of a closed session, so I'm very happy to have you there, and I will be available at the end of the session if you have any questions about what we do, about the methodology, and so on. So what I will be presenting today is what we call the QoE snapshots. It's basically some benchmarking that we've done at Witbe over the different quality and performance of the different OTT applications and also legacy application in order to deliver the final of the Super Bowl. So for this particular event, we wanted to have a strong focus on giving the overview of what is the quality on the different environments. Just a quick word about Witbe in order to start. Witbe, we're a software company, and more than 300 customers benefit from our product. So we work with all the majors, telcos and broadcasters in Europe and also in North America, including US, Canada, and also in Latin America. Just quick words about the company itself. Witbe has been founded in 2000. Headquarters in Paris, and now we work in more than 45 countries. We have 9 locations, including in the US here, New York, Denver, San Jose, and also Montreal in Canada, as well as London, Dubai, Paris, and Singapore and Hong Kong. So just a quick introduction. What is quality of experience? Because quality of experience is a word that a lot of you can hear now and then. On the different parts, you can see that on the encoding part, on the transcoding part. And Witbe, in our brand itself, quality of experience has been at the foundation of the company. So what is it? Basically, what we consider being quality of experience is how the service is perceived as an end user. And our idea is that our fundamental is that in order to measure quality of experience, you have to be like an end user. So what will be the KPI? It's fairly simple. It will be availability. Is it working or not? Performance. How long does it take between I launch the video and I have the video being processed? But also for any type of transaction, logging, search, or even subscription, two-factor authentication, or anything. And is the application performing okay? And is the quality, but really the visual quality, okay? That means no rubber frame events. Is there any macro blocking? Is there any jerkiness? Is the video smooth? Or is it blurry or very nice and clear? And how we do that is we do this how you would do it yourself. That means testing it. If you want to make sure that the video quality is correct, why not just look at it? We don't try to use all the technical information from the player, from the stream. We directly look at the video itself. And for that, we have robots. All robots are automated users that look and watch at the video the same way as you would do it yourself. And this is an example from the first QoE snapshots that we did. Here you have basically a robot connected to a smartphone. So it's it was on this one a real iPhone 8 connected to the robot, and the iPhone interact with the device like you would do. So it launched the application, and the nice thing is that you don't have to modify anything in your application. No code to modify, it's really a black box user. That's why we have been able to test it on the BBC iPlayer, BT Sport, and Sky in the UK, on a normal stock iPhone, no modification on the device itself. And the robot launched the application, try to log in, try to look at the video, and measure the video quality as it's being perceived. All the results are reported in the cloud. So after, you can have access to all the different results and have the pretty nice and neat dashboards. Over the past months, we have been doing that 4 different times, focusing on different type of services. So the first one was based in UK, with a strong focus on mobile devices for mobile applications. Second one was in the US comparing the different applications on Apple TV. So basically, we compared YouTube TV, Hulu, DirecTV for the live distribution in order to measure initial buffering time and video quality based in the US. Third one was focusing on the mobile carriers themselves. So in Canada, we have been measuring Netflix and YouTube in order to make sure that it's working properly by just changing 4G, 3G, different SIM cards and different provisioning profiles. And all these results are publicly available, so I encourage you to have a look at our website. You will have all the details. And today I will be focusing a bit more on the fourth one, the latest one. Of course, we will be publishing some new, but the latest one was done during the final of the Super Bowl. And as it's one of the biggest events, we really wanted to go a bit larger than what we've done previously. So we took the opportunity to have robots in all our offices, so London, New York, San Jose, Montreal, and Paris. And we measure unique configuration by changing the provider, by changing the box, by changing the application, by changing the channels. And we have had very interesting range, including some pure legacy product like cable devices like the AT&T. We have several X1 devices as well. Plus we have second screen, smartphone and tablets and web applications, and also OTT applications running on Roku, Android TV, and Apple TV. So it's quite a unique combination, and we are very proud to be able to show you this kind of results. And because the Super Bowl is not only US based, we also did some measurement in France directly on the DTH broadcast TV and also on OTT applications and pure native IPTV. So that gives you a wide range of transport. So you have DTH, cable, OTT, IPTV, of encoding, because all these companies use different encodings, devices from Apple TV, Roku, native telcos devices, as well as all the applications and channels. And we focus on three main KPIs, because in the end, this is what your user reports. What they report is, I cannot play the video. I was not able to launch the application. The quality was not good enough, and the initial buffering time was not good enough. So we really focus on measuring these different KPIs. Global availability means it's end-to-end. It's not only the player telling you that it's working. It's between I press OK on the application and I have the video with motion, no black screen, no frozen picture, no error screen, sound is correct, and video quality is correct as well. Initial buffering time, it's really what you measure visually, between you press play and you have the video motion appearing on screen. And the VQ score, so at Witbe we have been working for more than 15 years on this algorithm. We have our own VQ, video quality MOS algorithm, with the idea from the day one design is that it must run on any stream. That means you cannot know the reference, because this is the request of a user. You cannot know the stream in advance in order to monitor the quality. It must run in real time. No post-processing after all. It's really in real time on all the frame, not downscale, really on the full HD or full 4K streams. And it must run on any devices without any prior knowledge of the stream itself. So we don't have to know the codec, we don't have to know the transport, we don't have to know anything. It's really like you would do as an end user. It look at the screen, HDMI output clear, and it's looking at what is the perceived quality. And of course, it works with any normal stock devices, including Apple TV, for example. Here what you can see is a remote eye controllers. We have a visual real-time feedback, audio and video from all the different devices which are scattered around the country. So what are the results? First thing, congratulations to you all the availability was top-notch. Over the 800 unique viewing sessions that we did, because anytime we do a test, we try to do new viewing session, everything went perfectly fine. We had only 3 failures over the 800 viewing session, which is much better than it was in the past, especially on those OTT applications and OTT devices. That means the load was properly handled, and that means basically you've done a good job here. As the robot is recording everything which is being performed, we can see what are the errors. So here you have, because we had only 3 errors, but we wanted to show them anyway. So one error was during the login process, which is crucial when you have an OTT application. A lot of our customers are strongly focusing on the login, especially when you have third-party login. You know, like you can use your telco login and password in order to subscribe to HBO Go, for example. Especially with those new two-factor authentication login, which can be very hard to test, and the robot does it for you and tests the two-factor authentication by using a second screen device. Second one was a playback issue on the Molotov application, measured on the Android TV. And basically, when we press play, it started to load, and after we went back on the home screen, not playing back. After a retry, it worked, but anyway, we wanted to highlight these 3 errors. And we've been able to highlight them because everything which is being done by the robot is being recorded for further analysis. So now on the availability, it was okay. And what was the status on the video quality itself and on the initial buffering time? So on the video MOS range between 1 and 5. 5 being perfect quality. That means visually you have all the details, no visual macro blocks, all the frames are being very smooth, and no visual blur. 1 being you cannot watch the content at all. And what we have seen is that it was quite high between 3.4 and 4.4. So for the Super Bowl, which is a major live event, users want to go more on the high end. So between 4 and 4.4 is extremely high quality. You will see some example. 3.4 is watchable, but it's not so good, meaning that if you do that on a big screen, you will not have the very good quality. Second screen range from 2.9 to 4.0, so slightly lower, which is expected, especially on the web applications. We know that different broadcasters and telcos and cable operators tend to compress a bit more aggressively their content when they want to push it to second screens. Regarding the initial buffering time was between 2.1, which is very good. It's really on the best end that you can expect, up to 17.6 seconds. 17.6, you can see it's going a bit out of the screen. It's not at all what you expect, especially when you are looking at live content. You expect it to be much between 2 and 6 is acceptable. Second screen was very good, between 1 and 3. So, and you can see all the results. It's quite, here I don't expect you to be able to read anything from here. But all these results are available on our website, and you can see all the details for all the different combinations. So, quick word about the quality itself, so that you can perceive what are the differences between 4.4 and 3.5. Because you say, okay, 3 is not good, but what does it mean from an end user point of view? So this is a 3.2 measurement. This one is a 4.4. So it's slightly compressed, but in order for you to see, I did an extract from a bigger piece. So here it's this smaller piece. Here it's this one. And here you can see that it's heavily compressed. That means a lot of macro blocking, slightly blurry between absolutely no details on the grass itself, and a lot of macro blocks. So these are the 2 artifacts that put this score so low. It was blur as measured as an end user, and macro blocking. On this one, you can see that the details are very crisp, no macro blocking, and very little blur, even during the movement, because our algorithm is able to make the difference between motion blur and between blur induced by the compression. That way we can really give the video scoring as an end user would do. And regularly we do new campaigns in order to see how the users rate real videos that we've taken from the field in order to continuously improve our algorithm. So we can just take a look at the top tier. So top tier video mass scoring above 4. So what you can see is that all of these have had very good quality. So between 4 and 4.5 is high quality. And the one thing which is unique to this year is that the top scoring was on an OTT device. So over the past few years, we have seen that the quality for OTT was okay. It was best effort because you have several encoding and the device choose its encoding profile. But in the end, was the quality top notch? Was the quality at the highest level of what you can expect? And now, for the first time, you can see that on the big screen, out of all the configuration that we've measured, including some legacy cable set-top boxes, HD set-top boxes, X1 devices as well, we have measured that the best quality was on Apple TV with a DirecTV Now application on the CBS channel. And the good thing, and which is very big up for the guys, is that they've been able to score the highest quality while scoring the lowest initial buffering time, which is really unique in what we've been able to measure so far. Usually, either you choose quality or you choose initial buffering time, but being able to do the two at the same time is very good. Second one was on DVB-T in France, very high encoding. And very close, we have the different combinations. So Apple TV again, BT in the UK, satellites, Apple TV again, Roku, and Apple TV. So you can see that on the top scoring, you don't have some legacy products. So you can see that the current cut the cord phenomenon is going to be amplified by that kind of quality. Middle one, you find all the native IPTV and native cable operators. And I won't focus on the last one, but you will be able to see them on the website if you want. But we have been seeing one which was able to have at the same time quite low quality and quite high initial buffering time. So for sure that we need to work a bit in order to improve these two factors, but a good way to improve is to be able to measure it. And a last thing that we've seen during all this analysis of the result was the challenge of dynamic ad insertion. Because out of the qualities that we measure also sound and video. So we measure black screen and we measure sound availability. So we did not specifically look at it, but when analyzing the results, we saw some intermittent black screen. So this one, for example, lasted 12 seconds. So we wanted to know why it was lasted 12 seconds. So we compare with the different other configurations that we've been measuring, and we saw that it was due to dynamic insertion. So you all know that the price of advertisement during the Super Bowl is one of the biggest for all the events. And here, having 12 seconds of content that have not been pushed during this window is quite of a lack of incoming. It was a bit quick, but I want to thank you all. So all this content is available in details on our website in the blog section. We have a booth right here. You can see it from here. And I will be available just after the session because we have been asked to not do Q&A during the presentation. I'm here available right now or right after at the booth. Thank you very much, everyone.